Here we have a SAT math question. Okay, let's go to the question. The quadratic function f of x equals to x negative 16 whole square positive d can be rewritten as f of x equals to x negative 10 times x positive c. What is the value of d? Okay, so we have the same quadratic equation in different forms. So the first one is in vertex form. The second one is in intercept form. Okay, first let me write the quadratic vertex form of a quadratic function in general. That is f of x equals to a times x negative h the whole square positive k. So this is a vertex form of a quadratic function in general. In this vertex form, so h comma k represents the vertex of the quadratic function over here. So the value h is nothing but the 1 which is in subtraction of x over here, and k is the value we have over here. Okay, now comparing the vertex form quadratic function that I have written over here and the vertex form of the given quadratic function over here. So what values do I get for h and k? At the place of h we have 16. At the place of k we have d. So let me take the vertex form of the given quadratic function, that is x negative 16 whole square positive d. Okay, so for this quadratic function, at the place of h we have 16, so 16 is the x coordinate of the vertex, and at the place of k we have d, so d is the y coordinate of the vertex. So this is the vertex for the given quadratic function. Okay, now our aim is to find the value of the y coordinate of the vertex, that is the value of d. Okay, now let me consider the intercept form of the given quadratic function, that is f of x equals to x negative 10 times x positive c. Let me take it over here. So f of x equals to x negative 10 times x positive c. Okay, now I can find the two x-intercepts of this quadratic function easily by setting f of x equals to 0. When f of x equals to 0, then the stuff which is equivalent to f of x also must be 0. There is x negative 10 times x positive c equals to 0. So the product of these two quantities equals to 0. Either the first factor x negative 10 must be 0 or the second one must be 0. Okay, so when I solve for x in this one, I have to add 10 to both sides. When I add 10 to both sides, this negative 10 positive 10 will cancel out. I'm getting x equals to 10. And so here to solve this equation, I have to subtract c from both sides. When I subtract c from both sides, this positive c, negative c will cancel out. I'm getting x equals to negative c. Okay, so the two x-intercepts are 10 and negative c. I mean, the x-coordinates are the two x-intercepts are 10 comma negative. So we can write the x-intercepts. That is 10 comma 0 is the first x-intercept, and negative c comma 0 is the second intercept. Okay, now what I'm going to do is I'm going to find the average of the x-coordinates at the x-intercepts. To get the average of this these two x-coordinates at the x-intercepts, what I need to do is I have to add these two values and divide by 2. So the average of the x-coordinates at the x-intercepts must be equal to the x-coordinate at the vertex, that is this average value must be equals to 16. Not only in this quadratic function, in any quadratic function, so it will work. So that is whenever you find the average of the x-coordinates at the two x-intercepts, it must be equal to the x-coordinate at the vertex. Now we can solve for c in this equation, that is 10 positive times 9 will become negative c over 2 equals to 16. Okay, to solve for c, I have to get up this 2 over here. For that, I multiply both sides by 2. So then 2 will cancel out. I'm getting 10 negative c equals to 16 times 2 is 32. Okay, now let me write the same equation over here. 10 negative c is equal to 32. Now I subtract 10 from both sides. When I subtract 10 from both sides, the positive 10, negative 10 will cancel out. I am getting negative c equals to positive 22. When I simplify 32, negative 10. Okay, my aim is to get the value of c, but here I got the value of negative c. To get out the negative sign, I have to multiply both sides by negative 1. Let me do it. Negative 1 times negative c, negative 1 times 22. I have multiplied both sides of this equation by negative 1. So negative 1 times negative c will become positive c. Negative 1 times 22 will become negative 22. Okay, now I got the value of c. Okay, now we can write the intercept form of the quadratic equation as f of x equals to x negative 10 times x, and instead of this positive c, we can plug in negative 2. So now the intercept form of the given quadratic function is complete, because in the intercept form of the given quadratic function is incomplete because there was known constancy, but I got the value of c, that is negative 22. Now the intercept form of the given quadratic function is complete. Now I can go to Desmos graphing calculator. I can sketch the graph of this quadratic function. Then I'll be getting a parabola. So when I get parabola and Desmos graphing calculator, so I can compare the vertex of the parabola and Desmos graphing calculator calculator and the vertex which we got over here. So when I compare these the two vertices, the vertex which I get from Desmos graphing calculator and the one we got over here, so easily we can compare, easily we can get the value of D. Since it's digital SAT, we can use Desmos graphing calculator. Okay, now we can move to the Desmos graphing calculator. Here we have Desmos graphing calculator, and this is the vertex already we got it for the given quadratic function, that is 16 comma D, and this is the intercept form of the given quadratic function. Now I'm going to give this intercept form quadratic function as the input over here to get the graph of this quadratic function, that is parabola. Okay, when I give this quadratic function as input, instead of f of x, I have to use y in Desmos graphing calculator. Okay, now let me give the function as input, that is y equals to x negative 10 times x negative 22. Okay, now I just gave the given quadratic function in intercept form as input. I got a parabola over here. Okay, now what I need to do is in the parabola, I have to look at the vertex over here. The vertex is, look at here, that is 16 comma negative 36. So this is the vertex. We get it for the parabola, for the given quadratic function from Desmos graphing calculator. Already we got the vertex that is 16 comma D. We just compare these two vertices. So here in our vertex, the y coordinate is D. So in the vertex of the parabola over here, the y coordinate is negative 36. So then D must be negative 36. So I got the value of D. So the value of D is negative 36.